Good morning, my YouTube viewers. It's Crystal here. I'm doing a code review on this volunteer data set. It's volunteer, it's task number 2. And the first data set that we used, it was task number 1. And I think I did the code review, I think I did it on TensorFlow. On task number 2, I couldn't really do it. It was totally alien to me. It was something that I had never seen before. So I messaged the sponsors of the competition and I asked them if they could do a starter notebook because I'm here all on my own. I don't have anybody to help me. And so they did a starter notebook and they used libraries that I had never heard of before. So there was no way that I could do this competition unless there was a starter notebook. So I used the starter notebook to enter the competition and I got a 78% on the starter notebook. So I created the program on Kackle's free online Jupyter notebook, and it's stored in my account. And what I will do, I will leave a link to the account in the description box down below so you can look at the notebook. And the problem statement is predict on volunteers during COVID in China, task 2. And I've previously done task 1. So the first thing that we're going to do is we're going to import the libraries that we're going to need, such as NumPy, SNP to create NumPy arrays and perform numerical computations, import pandas SPD to create data frames and data processing functionality, import OS to go into the operating system and retrieve the files that you need to run the program, import matplotlib.pyplot as PLT to visualize the data, and import Seaborn as SNS to statistically visualize the data. And then so after we have imported some, not all of the libraries that we're going to need, we're going to retrieve the files using OS. And you see that when we retrieve the files, we have 5 CSV files that go with this particular competition. After we retrieve the files, we use pandas to read the files, and we call the files train test, train edge, candidates, and submission. So you can see this is the train file. It is 382,384 rows by 12 columns. And what we're going to do is we're going to check the dates, the min date and the max date. So your min date is 20/10/1 and your max date is 21/8/5. Then you check your train edge. So there's your node 1, node 2, and weights to that node. Then we check the test file, which is 337061 by 13 columns. And then we check the minimum and the maximum date. So the min date is 2020-02-11 and the max date is 2021-08-05. Now we look at the candidates, and so this is the ID number, and this is composed of the node and the edge, and that's what they do. Then we check the submission, and so on the submission you have your ID and then you have your prediction. And so that's your ID for the candidates. And that's your predicted for what your prediction is. So now you want to know the average number of tasks a volunteer will participate in. So for the train user, it's going to be 239.13, and for the test user, it's going to be 293.43. So that's the average number of tasks an average volunteer will participate in. So now what we're going to do is we're going to construct the graphs, and we're going to use import networkx as index. So I'd never heard of networkx, but that's the library that you use to construct graphs. So I could not do this competition question unless I had the starter notebook, because I'd never even heard of networkx as nx. So data equals pt, pd, concat, train test, ignore index equals true, and then so you have 709,445 by 13 columns. So now we create the nodes and collect the attributes. So there we go. We use this nx for U and nodes, and we use this and we create the nodes and collect the attributes, and there's the code to do that. We encode category features, user location, so you encode the user location. So what they did is they put it in a dictionary to do it. And then we add the location attributes to each node. And then we create a networkx graph and add nodes. So you create a graph. And here's your graph, but doesn't give you a graph. And then we add edges to the graph here. And now you get your number of nodes and number of edges. You have 2675 nodes and 30219 edges. Now we train the model, and they use a model called Jacquard coefficient to make the prediction. So this is your prediction. And this is something that I added to it. I added a seedborn so you can see how many zeros you have. And it goes all the way up from 0 to 1. So it's anything 0 to 1. And then you prepare your submission by you make prediction, the predicted column, and you prepare your submission. And then what you do is you save it and you submit it to Kaggle. And I got a 78% when I submitted it to Kaggle, but there was no way I could do this unless we had a starter notebook, because I've never heard of the networkx library. So that's something that I'm going to have to study. And so there's your code review. It was quite difficult. You had to use a lot different machine learning techniques to do it. But we got there in the end with the help of a starter notebook. So I'm going to go ahead and conclude this presentation because I did the code review. And I would like to thank my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching this video. I look forward to making more videos for you in the future.